Welcome everybody. Thanks for coming by after lunch. Hopefully everyone's not too sleepy. This is Building Resilient, Scalable Services with Microsoft Azure Service Fabric. I'm Vaslav Turchek. I'm a program manager on the team.
Hi, I'm Vipul Modi. I'm one of the principal engineering manager on the Service Fabric team.
And today we're going to show you how to actually build applications on Azure Service Fabric. We'll look at the APIs a little bit and talk about how things work. And of course, there will be code. So then we'll show you how you can then take what we built and go and scale that out. But first, so we'll take a quick look at what Service Fabric is and how applications are architected. In case you missed Gopal's excellent talk this morning about the architecture of the system, Service Fabric is an application platform for distributed applications and services. At Microsoft, and especially within Azure, we've been transitioning these big monolith products like SQL Server, System Center, Link, and running these as cloud services. So we needed a new kind of PaaS solution to take on this challenge, in addition to all the capabilities that you see here, like high availability at scale and running at high density to reduce costs. So we realized that we also needed agility in large development teams when developing these services. We had to transition from large monolithic applications to applications composed of a set of smaller services that feature teams could build and ship and iterate on independently. So this is what's commonly referred to as a microservices architecture, and this is kind of the pattern that emerges naturally when you're building on Service Fabric. It's important that services can not only scale independently, but they also need to be developed, released independently. As some parts of large applications, they tend to change at different paces than other parts of the application. So Service Fabric was the solution to these challenges. It, of course, runs on Azure, but it can also be run pretty much anywhere where there are servers. So that's host clouds, on-prem, anything like that. It's essentially the abstraction layer between your application and the underlying infrastructure. So Service Fabric was actually conceived of nearly a decade ago. It's been in development and in use at Microsoft now for over 5 years. It's used from everything from transactional consistent database applications like Azure SQL DB to low latency and high throughput consumer-facing applications like Bing Cortana. So now, after years of use in production internally and being battle tested against these kinds of high-scale services, we're putting this platform into your hands now. And this isn't some watered-down, forked version of the code or anything like that. This is the real deal. You get the exact same platform that all of these services are built on today, including Azure SQL DB, DocDB, Cortana, and all these other large-scale services. So let's talk about how it actually works. The basic idea is that Service Fabric provides an abstraction layer for your applications over the underlying infrastructure. So we separate the host out from the application. What this means is that you can not only run Service Fabric in the cloud or on-prem, but your services themselves actually only need to be written once, and then you can go and deploy them anywhere where Service Fabric is running. So you start off by creating a cluster. And a cluster in our terminology is just a set of machines or VMs that are running Service Fabric on them. And Service Fabric goes and stitches these machines together to form a cohesive, logical view of those machines. And once they're a part of the cluster, we then refer to them as nodes, which is kind of our abstraction of a VM or a machine. So this cluster can start as small as 3 machines. You can scale it up to thousands of machines if you want. They don't necessarily have to be all the same. You can use small VMs, large size VMs, whatever you want, all in the same cluster. And this cluster, by the way, this actually will run also on, this will run on a single box. So you can actually take that cluster that you're going to deploy out into the cloud or whatever and run the entire thing on a single machine. And that's how you do development on Service Fabric. So you don't get some wonky emulator or simulated environment or anything like that. You get the actual production environment running all on your local box. So with the SDK installed, it's really just a simple PowerShell command to get that going. You run this command, and you've got a cluster running on your machine. In Azure, setting up a cluster will actually be offered as a service. So you click a few buttons in the Azure portal, and you got yourself a cluster. So the next thing you do once you have your cluster stood up is you go and start building your applications. And applications typically in this world are composed of discrete microservices. You can do as many services as you want in an application. You can do one service. That kind of thing is really up to you. Once you've built out these applications, you just go and tell Service Fabric to go and deploy these things on your cluster. So once you have this cluster up, it actually stays up. So you don't go through this process of tearing down VMs and putting up new VMs whenever you want to deploy applications or update applications or things like that. You're actually just deploying applications to the cluster, which is staying up. Service Fabric is going to then determine the best place to run them, and based on available machine resources and based on the custom metrics that you can define for your services. So whatever your services need in order to run, we'll take that into consideration and then load balance that across the cluster for you. Now, when a machine fails, of course, what happens? Well, luckily, Service Fabric is aware of this machine failure, and it's going to go and take whatever services were on that machine and redistribute them across the cluster automatically. Again, based on machine resources that are available and the sort of metrics that your services require. So it's a bit different if you compare it to what we have in cloud services today in Azure, where you're running on worker roles and web roles. So in Azure today, your services are actually represented by a VM role, right? Like a worker role or web role. So you're actually deploying VMs more than you're deploying applications. So for example, if you have 10 separate workloads that you want to deploy, that means you're going to have 10 separate worker roles, which means at minimum you've got 10 VMs you need to stand up. And so that can get pretty expensive. We call this hosting density, right? So the density of your applications running on your infrastructure is pretty low. With Service Fabric, though, you're actually just deploying the services, and the machines are already there. So you can take those 10 same workloads and deploy them on one machine now if you want. Or you can take 1,000 services and deploy them across 5 machines if you want, that kind of thing. All of that is possible with Service Fabric. So applications you build, as I mentioned, are composed of services. We actually define services in 2 different classes. That's stateless and stateful. So stateless services, this is what you typically just call services today. But we call it stateless because we need to make a distinction to say that that service itself doesn't actually maintain any of the important data that you want to keep. So like user data, for example. You persist that stuff. Oh, thank you. There it is. With a stateless service, you go and persist that important user data that you want to keep off to some external store like a database or table storage or something like that. The service itself might have temporary state that's used during execution. But the point is that if that service host goes down or if it gets restarted or something like that, whatever state was on the service is now gone. So this is what you have today, for example, with worker roles and web roles and cloud services. You can certainly write this way in Service Fabric too. There's nothing that's stopping you from doing it. But the important thing to note is just that we make this distinction because in Service Fabric we introduce the concept of stateful services. And we mean truly stateful services where the service itself actually maintains that important data that you want to keep. And that data is then co-located with the code that's using it. So Service Fabric takes care of that application state for you through replication and local persistence. This is really the democratization of high availability. So everyone, not just databases or high-end stores, can now have HA in their applications through Service Fabric's simple programming models and with full data consistency. And we'll show you the programming models here today. So we have these two options of stateless services and stateful services, but you can also use existing apps that are written on other frameworks. We support that as well. It doesn't prevent you from using, say, Node.js or a Java application or something you have. Go ahead and run those. Or if you just have any random executable, go ahead and run it on Service Fabric. Totally fine. We'll basically take that, host it, manage it. We're going to make those runtimes reliable if necessary by ensuring that the needed number of instances are always running. You still get all the full benefits and deep resource balancing that Service Fabric offers. And you can reuse this existing code. So the real benefits of Service Fabric, though, comes when you actually use our programming model layers and our SDK. To build applications on Service Fabric, we give you two high-level APIs that we call reliable actors and reliable services. So you can build applications that are composed of both APIs. You can have services that use actors. You can have a service that is just built on the service layer. You can compile those into the same application and put that up. You get all the benefits of the platform irrespective of which one you choose. So we'll take a look at the Reliable Actor API first. So the Reliable Actor API is based on the virtual actor model, which is a model of concurrent systems that actually originated in the 70s. So it's meant to make reasoning about distributed systems much simpler, much easier, by representing units of state and computation as a single threaded model, essentially. The actors are actually, they're very similar to .NET objects. You can kind of think of them that way. So they represent some state and some logic, and you can basically call methods on those things, and they're all independent of each other, and they all kind of scale independently. In the Service Fabric Reliable Actor API, we take this concept and we apply it so that you get all the benefits of the platform in a very easy-to-use way. We handle the distribution of actors. We take care of the communication with the actors, so you don't have to worry about how am I going to connect with these things. We handle all that kind of stuff for you. And the framework actually provides automatic state management and simple turn-based concurrency model that eliminates the need to write any synchronization code. So, of course, this all makes a lot more sense when you actually see how it's written. So we'll bring Vipul to walk us through an actor service here. There we go.
So 7. Okay, so as was mentioned, that actors are just like objects. So obviously, when you write .NET objects, you start with an interface. So for microservices, you start with a well-defined interface. Now, in order to build this microservices, we provide a deeper integration with Visual Studio. So if you go to File, New Project, and you can see all the templates that you can do. So you can build the application with Actor APIs. You can also build application with the Reliable Services API that we'll see in a moment later during the presentation. So I've gone ahead and created a project based on the stateless actor service. And as I said, that you start with basically an interface for your actor. So you start with an iCounter actor interface in this case, which is simply a counter. And you can think of a counter for counting, let's say, request. It's a performance counter, or maybe some other sort of counters like a flow control or anything that you want to use in your application, right? So this counter has two methods, which is basically set and get. And it has a simple or more sane compare exchange method, which is what you want to use when you're programming in a distributed world, right? So now, first thing, you need to define your actor. Second thing, you need to implement it. So in this case, I've implemented the actor by deriving it from my counter actor from an actor. It's implementing the iCounter actor interface that I've defined. And I'm storing the counter value as a member variable in my actor. Now, for a compare exchange, obviously, all I'm doing is basically comparing the previous value, and if the previous value is the same as what is being asked, then I go ahead and replace that. For get, I'm just returning the value. For set, I'm setting the value. So you'll see here is that this is a very simple implementation of, for example, you can call this a distributed counter, right? I haven't written any synchronization code. The framework provides the turn-based concurrency, as was mentioned. The third thing that you need to do, so you define your interface, you implement your interface. Now you got to tell the runtime about your actor, right? Otherwise, how are we going to instantiate it? How are we going to fail over it as needed? So the third thing that you do in your EXE is you say, hey, I'm going to go ahead and register this counter with the runtime. So you create a runtime, which is the Fabric runtime, and you register your actor, and then you wait for the actor to get activated and get the calls, right? So let's go ahead and deploy this into a local 9-node cluster that I have. So as was mentioned, once you install the SDK and run the setup script, it will create a 5-node cluster. In this case, I'm using a 9-node cluster. This is all running on a same box. In production, these nodes are basically going to be one per one with respect to the machine. You can run them in a scale minimize environment. It is not an emulator. It's exactly the same code as it runs in production. And so when you are writing your application, deploying and testing it, you will see that you will get the exact same, you're running on an exact same platform. So I'll go ahead and deploy this solution. So while it is deploying, let's see how would I use this actor. So in order to connect to the actor, you create a proxy to it and say, hey, I want to create a proxy to iCounter actor, and I want to name that actor. So you have to name the actor. The actors are virtual. They always exist. So you don't need to explicitly create them. But in order to address them, in order to talk to them, you need to provide an ID. And so that's this actor ID. Your IDs can either be a string, they can be GUID, or they can be a long IDs. So I connect to the actor through actor proxy. I give it an actor ID and the name of the application in which this microservice is running. And then all I do is that I go ahead and get the value of the counter. Using compare exchange, I go ahead and increment that counter. And then I do this continuously, right? So let's go ahead and see how the application is deployed in the cluster. So this is the 9-node cluster that I have.
So what you're seeing here is this is actually a tool that ships with Service Fabric that kind of lets you explore. It'll give you a view of the nodes that we talked about earlier, which is creating your cluster, and then the applications that are running on top of it.
Right. So as was said, that what you run in your cluster is basically application consisting of microservices. So here I have this counter actor application that we just created. There is a counter actor service. This is one microservice. And it has one instance which is running on node 3. Right? So let's go ahead and connect to that through our client program. And you can see that the actor proxy connected to our actor, the actor got instantiated, and we're just incrementing the count in that loop. So now let's go ahead and, while the client is running, shut down node 3. So you'll see that the node shuts down. The system detects that this particular microservice that was running on node 2 is no longer there. So it needs to basically build that somewhere else in the system. So it activated the actor on a different node. You'll see that this time it's on node 7. Let me stop auto refresh here. So it's on node 7 now. I'll refresh this. So the actor is running on node 7. So we just saw a failover in action. We wrote a very simple counter actor and deployed it within the cluster, a node fail, which is equivalent to a machine failure in the production environment. And our code came back on a different node. When I wrote the code, did not think about machine, did not think about, oh, what will happen if a machine failure were to happen. Service Fabric takes care of that. One other interesting thing, if you notice, happened here is that we actually lost the count. And well, that's true because what happened was that we store so if I go back to my code, in the counter actor, we were storing the state in a local member variable. So when this actor gets activated somewhere else, well, that member variable is going to get initialized to 0 again. So we lost the count. So I'm going to stop the client. Let's go ahead and see how we can make this, the state as well, reliable as well. So we made the code of an actor service reliable. We want to now make the state reliable as well. So for that, what you do is that you define your state, any serializable state. So in this case, I'm defining a counter state. It has a value. And then you derive from an actor of T state. So here, our state is counter state. So now I no longer need to have a member variable. This base class has a state property that's actually consistent. It is replicated and it's made durably available to n replicas. And so this is a consistent, reliable state that you will get. So all I do is that in order to access that state, in order to modify that state, I do that through state property. You'll notice here again, I'm not writing any synchronization code, any lock management code. Every time an actor is activated, the value of the property is consistent. It is the last value that you have written or modified before a failover happened. Whenever I'm setting the value to the count, I set the state to a count that I want to save. Once the method returns, the framework will reliably make n copies of it, store it on other nodes within the cluster. So let's go ahead and deploy this. Actually, this time, rather than deploying, I'm going to press F5 to show that we also have a Visual Studio debugging integrated into this. So as the microservice is deployed onto the node, Visual Studio will attach and did I do so?
So this tooling, by the way, this comes and ships with our SDK, which you can go and pick up now. Actually, it's available. We'll show you where to get that at the end of the talk. We have the so F5 integration. You just write your services and you hit F5, and it's going to go and deploy the entire thing basically to your local cluster.
Okay, so we shut down the node. We didn't bring the node back up.
We didn't bring the node back up.
How does the fabric know that that state is available? Is it just because of the way you created that object and made it a part of the generic?
So we'll take the questions in the end.
Okay.
So I've made the state reliable now. This is getting deployed. Let's go ahead and start the client so that we'll hit our breakpoint. So you can see the breakpoint is hit. It's saying that the previous value was 0 and I want to set a value to 1. I'll press F5 again. And you'll see that the previous value was 1. I'm trying to set it to value 2. So you get basically a full debugging experience of Service Fabric applications as well. So I'm going to remove the breakpoint, let this go, detach from the debugger because we want to go and do failover again. So let's go ahead and look in the cluster at the stateful service that we have. So here you can see that previously we just had one instance. Here we have a primary and 2 secondary replicas. So as the changes are made onto the primary, they are getting replicated onto the secondary, and you have the reliable state. So again, the primary is on node 3. So I'm going to go ahead and stop node 3, go back here, see, refresh this. You'll see that a primary went down and another replica was chosen as a primary. But voila, this time we didn't lose our state. So we're still, we counted up to 72, a failover happened, and then we counted again from 73. So the reliable actor got activated on a different node. So we'll see in this case, it's actually the primary is now on, node 7. And you'll notice that this replica, which is the one which was previously the primary, is still down because that node 3 is still down. However, we're still able to make progress in the client because later during the talk, we'll see that it's a quorum-based replication. So as long as quorum is available, your microservice is going to remain available. So I'll go ahead and start node 3. And you'll notice that this replica, which was down, it will come back up again as an inbuilt replica. So it's a replica which has lost some of the state changes while it was down. And so once it comes back up, it will go into standby. Service Fabric will make sure that all of the changes that it missed comes back to that replica, and then it is added into the active replica set. So I think that's the end of the demo for the Reliable Actors API. Back to us.
Thanks. Where do we go here?
5.
5? 5 it is. All right. There will actually be another talk about actors later this week on Thursday, where you can go more in depth into the actor programming model.
So there we'll talk about reminders, timers, many other actor feature. How do you do custom state management? Where do you store if you want to store state somewhere else? And many such in-depth feature of the actor programming model itself.
So I'm going to talk briefly, just real quick, about what happened when Vipul actually pressed F5 and Visual Studio went and did some magic, and suddenly we had an application. What happens is that there's an application model that's defined in Service Fabric. Services are actually composed of two parts. There's code and there's config, and the code is your binaries that are actually running your service. Config is any configuration that you want to use to configure your application. So we provide a structured configuration to use, and then you can also toss in whatever kind of free structured configuration you want. And that all ends up going into what we call a service package. So these two are packaged up, and what we call a manifest file is also included in here, which then kind of has some metadata that defines this entire thing. And the service package then is one unit of deployment and activation. And these things that are inside here, the config and the code that are inside here, they're also independently updatable. So you can go and do a config update without ever stopping your service and that sort of thing. So these two things then, they get deployed, they get packaged up into what we call an application package, and the application package is the thing that actually holds all of your services, whether they be big services or microservices, whatever you want. So this is kind of a quick look at the packaging model. Now what happens when you go and create application service packages, we're actually defining types. So we're defining application service types. And when we say type, I mean the same kind of type that you have in, like, say, C# in an object-oriented language. So it's kind of like defining a class. And then when you go and deploy this thing, you create instances of the class. So that means that you can basically define the thing once and then create as many instances of it as you want. And just like with an object, you can go and set properties on the instances. So I can take this application type and these service types, and I can deploy a bunch of instances, and they all have different properties set on them. So they have different values and things like that. And we'll give you an example of one of those in a little bit. So when you go and deploy them, they just end up on the cluster there. Each service and each application instance gets a unique name, similar to how if you go and instantiate an object to a variable, you have to give the variable a unique name, that kind of thing. So it's the same deal here. Each service instance has a unique name that you can then refer to it by. The application and service instances, they're also versioned. So this is one of the big differences between this model and, say, an object model, is that these actually have versions, and so then you can go and perform rolling updates on them without any downtime, that sort of thing. There's also isolation levels, process and file system level isolation here. Okay, let's move on to reliable services. So we looked at reliable actors a little bit. This is the other programming model that we offer in Service Fabric at the higher level. So in comparison with the actor API, With actors, we kind of set up a programming pattern for you to use, right? Actors is a pattern. With reliable services, it's a little more open. There's no pattern defined. You kind of do whatever you want to do. You get a couple entry points, and you just go off and you write your code there. So you have a little more flexibility in how you want to define your service. For example, you can take an existing ASP.NET application, and you can just host that in a stateless service and do it that way if you want. And you still get all the benefits of Service Fabric, like application lifecycle management and monitoring and failover and all that good stuff. As we mentioned earlier, you can also build stateful services with a little more flexibility than you get with actors as well. But you also have a little more control over how you manage your concurrency and granularity of the data that you use. And you go and manage these things through transactions. So you can achieve higher performance in cases when it's not natural to divide the state and processing into these multiple independent units that you would do with actors. You can also choose any communication stack you want to use here. With actors, we kind of handle communication with you. So when you go and talk to an actor, we kind of do that for you. With services, with the Reliable Service API, you get to choose whatever you want. So you can do HTTP with Web API if you need good interop between services. If you have existing enterprise services on WCF, you can bring those right over. We provide WCF out of the box. Or you can just use straight sockets or web sockets if you need maximum throughput. So let's take a look at writing one of these reliable services. Now, as is tradition, whenever you're presenting a powerful distributed systems platform, we're going to count some words. So this is actually a multi-part demo that's actually going to bring a lot of these concepts together for you, I think, and show you how it all works. So I'll hand it over to Vipul, who's going to start off with a stateless service.
Okay, so we wrote a distributed counter. Now we're going to count words. So this is my word count stateless service. I count the words as they come in, and I get the count back to the client when it requests that I want to get the count of all the words that you have seen so far. Now, in order to build a reliable stateless service, you would derive from a stateless service class, which is what I have done here. So I have a word count stateless service that derives from a stateless service, and it's implementing my interface. Now, the first thing that the runtime does is that once the service instance is brought up, it will ask you, hey, do you have a communication listener? Are you listening on some endpoint for the client request? And if so, can you provide me that so I can coordinate that? And then this communication listener has a simple open, close, and abort API, and it returns this address. So when the client requests, where this service is to Service Fabric, that is the address that the client gets, and then the client can connect using that address. If a failover were to happen and say, client says, well, I was connected to that address, guess what? It's no longer there. Service Fabric, can you tell me where the service is now? And Service Fabric at that time would have started this instance on another node, would have asked your communication listener through your service saying, hey, what is your new address? And that's the address that would have published in the naming service, the service that Gopal talked about in today's morning in the architectural talk. All right? So in this case, I'm creating a service communication listener. This is like an actor communication. We provide a communication out of the box. We'll see progression throughout the talk where I'm using service communication listener. In some of the other services, I'll use ASP.NET Web Applications. In some other, I'll use WCF. So you can use a communication of your choice. In this case, I'm using service communication listener. Then the second thing that the system does is that it says, hey, once your communication listener is booted, I'm going to run you this. So think of this as like your run method in the current worker role. So once everything is set up, the run continues. We pass you a cancellation token, which means that until the cancellation token is valid, you're good to process. Let's say if the system were to balance you on some other node because another service has come up or some other nodes have gone down or joined and we need to load balance, this cancellation token will be marked as cancel, and you can stop processing at that point in time. Your code will be teared down, and then a new instance will get created or moved on to another node, right? So you create communication listener, run. Now, what do I want to do in this service? Well, I want to count words, right? So typically what happens is that as the words come in, so if I'm writing a worker role application, I'll say, hey, as the words come in, I need to tell the client that I have received your word, I'm going to process it, and so what we do is that we typically store it into a queue. So in this case, I have a member variable, which is a concurrent queue. So as the word arrives, I go ahead and store it into the queue. I enqueue the word into the queue, and I say, well, yes, I have got the word. I'll process it. And now, obviously, when I count the words, I need to store I'm also storing the words. And if I see the duplicate, I'll just increment the count. So this word count dictionary is basically storing words and their counts. And this stats dictionary is basically storing the overall count into total words processed key. Now you could say, well, gee, why didn't you just use a member variable, a long variable? I could have. You'll see this, why I'm using concurrent dictionary for just counting the overall number of words when we move on to making this stateful. So in my run method, while there is an item into the queue, so I dequeue an item into the queue, I add it to my word count dictionary and say add an update. So if this is the first word I'm seeing, I'll make the count as 1. If I have seen this word, I'll just increment it count. And then finally, I'll update the overall words that I have processed. And I do this until the cancellation token is null. I'll sleep for some time and then continue doing this over and over again. Right? So let's go ahead and deploy this service. Well, obviously, just like the actor, you need to tell the runtime that, hey, here is the service type that I've implemented, and this is the code that is handling this service type. So you do the same thing. You register your service type along with the Fabric runtime in your main program. So let's go ahead and deploy this solution. So while this is deploying, again, we're going to look at what do we do in the client. So in the client, this is a very simple, like 1980s console UI. So what I do is that I initialize the UI, and then I say, hey, I'm going to start adding the word. So this add count, add word async is just in a loop. It's basically adding a new word. So it creates a proxy, just like actor proxy. I'm creating a service proxy to I hello world service. This is the URI of the service, and I add the word. I generate a new random word, a 5-character random word, and then call the service and say, hey, add this word for me, and then do that every 50 milliseconds. And then I also go ahead and update the count. So I basically update the counts, store them into concurrent dictionary, and then I have another task which basically just prints the count on the console. Right? So let's go ahead and see if the service is deployed and how it looks like. So here is, again, a word count application. There is a service, and it has one instance that is running in the cluster on node 7. Right? So let's go ahead, fire up the client. So we're adding the words, and then there is only one partition, as you can see, for this service, and we're counting the words. Right? So as we add the words are getting counted. Now, obviously, you know what I'm going to do next. So I'm going to simulate a failure. I'll go ahead and kill node 7.
Poor node 7.
It's node 7, right?
It's node 7.
Yeah.
We're always picking on node 7.
Okay, so I stop. You'll see that the service, the client will stop. It says, well, there are no more count updates, so it marks that as yellow. Again, you'll see here is that we lost the count. We were counting the words. All of these were stored in a member variable, and we lost the count. So we made the code reliable using the Reliable Services API, but the state is still not reliable. So how can we make it reliable?
So here's what you would do before. Here's what you do in cloud services today. So like we said, this is what we meant earlier by the thing is stateless. We lost all of our state, right? So when we're dealing with valuable data, like the number of words being counted, it's important that we don't lose that state. So in cloud services today, and actually probably in any other cloud offering you have, what you ended up doing is you start adding in these external dependencies to go and maintain the state. So for example, we go and add in an Azure queue instead of using that local variable concurrent queue so that all those things we put on the queue that are waiting to be processed don't get lost. Similarly, once we go and process the thing off of the queue, we need to store it somewhere so we don't lose that data, and so we spin up an Azure table or some NoSQL store or something like that. And this is what our architecture ends up looking like. Now, it's not to say there's anything wrong with doing it this way. This is kind of your usual 3-tier architecture. But the thing that Service Fabric lets you do is you can actually do a bit of a better job than this. So this is where we introduce reliable collections. Reliable collections are highly available, replicated data structures in .NET. They're designed to make your data reliable and highly available using a familiar collections programming model. It's a natural evolution of .NET collections. When we started with .NET, we had simple single machine, single-threaded collections like dictionary and queue. And then this eventually evolved into these sort of concurrent collections that were still single machine, but allowed you to do more multi-threaded friendly applications. Now with Service Fabric, we introduce reliable collections, which are multi-machine, replicated, transactional, highly available collections that still use that same familiar collections API that you already know. So today we provide 2 reliable collections out of the box. We have a reliable dictionary and a reliable queue. When you store data in a reliable collection, that data gets replicated and is durably stored on multiple service replicas that are then distributed across the cluster, so they're all living on different machines. Reliable collections, they support atomic transactional operations that can span multiple collections. So for example, with the reliable queue and with the reliable dictionary, you can pop an item off of the queue, do some processing on it, and then store it in a reliable dictionary. And you do this all within a single transaction, so that if any point during that processing, if an exception is thrown or one of your machines catches on fire and burns down, the entire transaction actually gets rolled back and you haven't lost any data because that item stays on the queue and then can be processed later on by a different machine. So this is the kind of thing that you don't really get today with external solutions like a queue, external queue, and external storage, because you're working across transaction boundaries, whereas here you are working within the same transactional boundary. Transactions also support. We'll come back to that at the end. Hold your questions for now. We'll come back to that. They do support repeatable read isolation, so it means that you can read values you wrote within the same transaction. And enumerations are snapshots, so they provide a consistent view of the data when the enumeration started. And by the way, speaking of enumerations, all these collections are IEnumerables, so you can do link queries on them as well. So then if we take that idea and we use that architecture, this is what our stateful word count ends up looking like. Instead of having all these external dependencies, we just have this nice, real simple application made up of 2 services. One is going to be that something on the front end to handle requests, and then all that logic, the queue, the tables, all that kind of stuff is actually contained within the stateful service, all inside there. So Vipul, why don't you show us then how to actually write that stateful version of word count?
So here is the same word count service. Instead of now, previously I was deriving from a stateless service. I'm now deriving from a stateful service. So now, also in the other thing that I've done is basically, remember the service proxy communication listener that we were using, or the service communication listener that we were using in service proxy to connect. Instead, I'm now using WCF communication listener. And so this I word count service is actually a WCF service contract. So this is just showing that you can use various communication technology within your service. Now, previously, remember I used to store the input as it arrived into this input queue, which was the concurrent queue. So instead of that, I actually asked the base class. So base class has this property called state manager, that state manager is the iReliable state manager. This is the state manager that's basically reliably managing all of these collections. It is the one that is replicating the data. It is the one that is providing transactions and atomicity within those transactions, right? So I asked that state manager, hey, I need a reliable collection and I need a reliable queue. And you can name your collections and you can create them as often as you like and how many ever you like. We'll see that you can do transaction across this collection. So here I'm naming it as an input queue. So you can name whatever you want. The names can be either string or they can be URIs as well, right? So I have a reliable queue. So I say that, hey, I need a reliable queue. So let's look at what does the add word looks like. So again, I'm asking the state manager to create a transaction. I say, well, I need a reliable queue. And using that transaction, I'm enqueuing an item into the queue, and I'm committing the transaction. When this transaction is committed, this item that I just stored into the queue is replicated and durably stored on a quorum of replica within the cluster, right? So now I've stored this item into the queue. In the run method, again, I wake up and I say, hey, do I have any items into the queue? If I have an item into the queue, I want to put it into this reliable dictionary, which is my word count dictionary. So previously, I had this concurrent dictionary that I was using in order to store the words. Here I'm asking the state manager to give me a reliable dictionary. Again, it's an iDictionary. I can basically store an iDictionary of a string and a long. And then the next thing that I'm doing is that I'm asking it to say, give me a stats dictionary where I can store the overall count. So this is the reason why I didn't use a member variable in the stateless service for storing the overall count. I want to store it reliably, and I want to make use of the reliable dictionary. This is typically how you would do. You would store it in your cloud service. You would have stored it in some other external database, as Vas mentioned, right? So I created those dictionary. And then I take an item from the queue. So I dequeue an item from the queue. As long as I have an item, I'll go to the word count dictionary, do an add or an update. So all of these code that was there previously remains exactly same. There is no change. There is no change whatsoever in that portion of the code. I basically do add or update, right? The change finally is I'm actually passing a transaction when I'm doing this operation, and then I'm committing this transaction. So now if you look here, I'm doing 3 operations on 3 different reliable collections, 1 queue and 2 dictionary. And they are all within the same transaction, which means that if my code were to crash somewhere here, let's say on this line, and I had already dequeued an item, since I haven't committed the transaction, that item still remains in the queue when the code is resurrected on a different node and made a primary. Right? So I'll still see that item. I'll go ahead, process that item. Again, same thing. If my code dies somewhere here and I've added it to the word count dictionary, if the transaction is not committed, it's actually not there. It's not even removed from the queue. So even when, let's say, I call commit async and my commit async failed because that's the time that failover happened, even then it is not removed from the queue. And so it's atomically consistent. The state is there, right? So let's go ahead and deploy this application into the cluster. So I'll go ahead, run deploy. And then we'll go ahead and see what it looks like. So I have word count application. It's still coming up.
So while this is coming up, you can see actually some of the benefits here. For example, all those dictionaries and queues are actually local to the service. So this is what we meant when we bring the state and co-locate it with the compute. So you're not actually making a network hop to enqueue something somewhere, and you're not making another network hop to go and pull it out of a dictionary or something like that. It's all actually localized there. So one of the external components we didn't show in that last architecture diagram was a cache, which typically you'd put in to increase your read throughput. Because you're making these network hops. But here you actually don't need that because it's all just local reads right out of memory.
Okay. So I'm going to run the client, and this time I'm trying to connect to a stateful service. So you can see the client is connected, it's counting. Let me refresh this view. So you can see here that I have one partition, one primary, and then again 2 secondary. So as I'm making these changes, those are actually getting replicated onto those secondaries. Well, look, this time we have primary on node 5, not node 7.
Oh, all right.
Okay, so next I'm going to go ahead and stop node 5. And notice what happens as the system detects that a primary has gone down. The same thing that you saw in the actor, another secondary becomes the primary. And you can see the service did not lose the count. So we didn't lose any of the items that we were putting into the queue. So the reliable collection, again, made it easier for us to write stateful services in a much more easier fashion.
Great. Let's talk scale. So
Yeah, so
how do we scale this thing
you
out?
want to show what it looks like right now? And then
You want to show what it looks like right now?
Yeah.
Yeah, let's show what it looks like right now.
Okay. So here is my word count. Well, this is the node that is down. So here is my word count application. You can see here I have a primary on node 7, right? And then I have 2 secondary, and then one of which it is down. So now let's say that if I were to bombard this with lots and lots of clients, well, my primary is the one that is doing read and write. This is not going to scale, right? So how do we scale this now?
Yeah, so let's take a look at that. So let me take a moment just to explain actually what you saw there. So to make these things highly available and reliable, we actually create multiple copies of the service instance, and that's what we call replicas. When we're referring to replicas, that's basically what we mean there. When we talk about applications and services, and we mentioned partitions briefly and replicas, in Service Fabric, it's the replicas that are the things that are actually physically placed on the nodes. So the application is just kind of a logical grouping of services, which is a logical grouping of partitions, which is a logical grouping of replicas. And the replicas are the things that actually get placed. So if you're looking at this, you're probably thinking the same thing as I am right now. If I have only one primary replica on one machine and it's getting all the writes and all the reads, how the heck are you supposed to scale this thing out, right? So with stateless services, it's kind of easy because you can just you can just go and say, create a bunch of instances of my stateless service, distribute them across the cluster, stick a load balancer in front of it, and I've gone and scaled out. But with stateful, it's a little more difficult. It's a little trickier. When you think about how to scale out a database, for example, when you actually have state, what do you typically do to scale out the database? Well, you can do a master-slave kind of thing to increase read throughput, which, I mean, we already have that here because we have 2 secondaries. So if you want to scale out further than that, typically you go and you start partitioning out your database. So if you have a database of usernames, for example, you could take username A through F, split that out, denormalize your tables, split that out, take that and put it on one machine. And then you take G through I or whatever and go and put that on another machine, right? And so you kind of scale this thing out that way. And then that, of course, you took one problem and now you have a whole bunch of problems, because what happens if, say, one of those machines, a sinkhole opens up underneath it and it drops into oblivion? Have you lost all that user data? Like, what happens to those users, right? So Service Fabric goes and takes care of all of these kinds of problems. And the way that we do that is with what we call partitioning. So when you deploy a partition service, you actually now have multiple sets of replicas that are all doing a portion of the total work. And this is the same kind of idea that we did with the database. We just take your total data, we divide it up into subsets, and we take each subset and we place it into different nodes. And so now it's all kind of partitioned out. So now all of your nodes are actually doing a small subset of what they were before. And if you have, say, for example, here we have a 4-node cluster, those primaries that are placed on those 4 nodes, those 4 nodes are now all doing all the work of all those primaries that are on there. So if you need to increase capacity and to scale this thing out, you want to go and add 2 nodes, well, we're going to go and automatically rebalance all those replicas out for you. So now all of your nodes are doing even less work than they were before. So if you reach capacity, for example, on a node, you add a few more nodes, we balance everything out, we scale you out, and now your nodes are doing less work than they were before. And so that's kind of how scaling out works in this world. The resulting architecture kind of looks like this, where you still have your load balancer and you still have some stateless service in front of it that is usually a web app or something like that, and that acts as your ingress point for user requests and things like that. And then you have your stateful services behind that, and that's the thing that actually holds your state and is scaling out. So it's similar to that stateful word count architecture that we saw before, except now we've gone and scaled that thing out. Vipul, you want to show us actually what that looks like?
Oh, yes.
Let's take word count and
yeah,
scale that one out. What do you think?
So
there you go.
Go ahead. So one of the other things that, so here is a word count application. This is what we call an application manifest. This is the one that describes the package that we saw previously, which had basically a big box, big gift kind of box, and then a little box going inside of those. Those were like the service packages. So in this case, I basically have two service packages, one which is a web service package, and another one is a stateful service package. And so I have a web application, which is the front end for my word count application. And then I have the stateful backend service. And I've actually partitioned the stateful backend service into 13 partition with basically that's starting from on the starting letters of the word. So this is what I've done. Now let's look at what it looks like actually in the real cluster. Well, before that, let me also show you that for my web application, which is my word count web service, it's a stateless service, and I'm actually using an open communication listener. So I'm basically hosting ASP.NET using using OpenHost, right? And again, my stateful service here, which is my word count stateful service, I'm back to using the service communication listener. So this is the typical architecture that we see in the application where you write this two-tier application where you have a front end, which is accepting either a REST or some other application-specific protocol which terminates the protocol, and then you go ahead and connect to your stateful services using service proxy, WCF, or any other communication technology that you want to use, right? So let's go ahead and see what it looks like actually in the cluster Service Fabric Explorer first. So you can see here, this is my stateful word count service, and these are all the 13 partitions with the primary and the secondary for each of those partitions. Also, let's look at how this looks like in that cluster viewer or the cluster monitor that we saw previously. So you can see here is that now I have this word count stateful application has multiple primaries and secondaries, so it has multiple partitions. Those are distributed across 7 nodes, and you might notice why the heck node 8 and node 9 does not have anything. So we'll see, think of this as that, hey, this node do not exist in the cluster, so I've deactivated those nodes using Service Fabric Explorer. And then what happens when they get activated, we rebalance. We'll say, hey, there are more nodes available. I have more units that I can move around because I have more partitions. And so the system will start balancing itself. So let's go ahead and do that. So I'm going to activate node 8 first, and then I'm going to activate node 9. So while the rebalancing is happening, I also wanted to mention that this cluster monitor was basically written as a sample application. And the APIs that you see, or the Service Fabric Explorer that you see, that's using our management API. This cluster monitor is also using our management API. So we provide management API that are basically C# API. You can use PowerShell in order to manage, monitor your cluster, as well as we provide the REST APIs. And so this cluster monitor is using the REST API. So we believe that eventually you guys will be able to look at this and say, well, they have Service Fabric Explorer, which is a good tool. They also have this sample cluster monitor. Maybe you can build more powerful visualization techniques or more powerful visualization application for visualizing, managing, and monitoring the clusters, right? So while this is happening, we want to go ahead and go look at the next through sessions that we have, right?
Yeah, let's take a look at that here.
Or you want to see the...
How's it going? It's going to take a little bit there. So we're actually almost out of time here, so we're going to let that scale out for a bit. In the meantime, we're going to ask everyone here to go download our SDK, start playing with the bits, get on GitHub, check out our sample code, start playing around with those, and also check out our tutorials and videos as well. And be sure to attend our other talks on Service Fabric later this week. On Wednesday and Thursday, we'll be talking more about deploying and managing these applications and services, orchestration of all the services, and then as well as a little more on actors too. So how's this looking?
So what I've done is that I've started, so this is, we didn't show the UI. This
hey,
is the
yeah, there you go. We do have a UI. Right,
for the word count application.
So it's a web application now, so it's just running in a browser, just using some JavaScript to go and hit the thing. So not everything you build has to be a console app, obviously. You can just sort of make whatever you want. So here actually you see, what you see here is the partitions are all listed out. If you go back to that UI real quick, you see the partitions are listed out, and as words are being added, they're actually being routed out into those partitions. Now, one thing to mention too is partitioning is a first-class citizen in Service Fabric. Like this is built in. You don't have to do this yourself. Actually, when you saw Vipul was showing you the application manifest, it's just a couple configuration settings, and that's it. You say, I want this many partitions. I want it to be in this key range. Go, and we do everything else for you. So that's all actually built right in.
Do you want to talk about this as well?
Chaos service. Are we ready to start Chaos?
Yes.
Okay. Go for it. So we also include a suite of testability tools so to go and help you test your services and applications as they're deployed. Okay, and here we go. The scale out actually finished. So you can see here, we didn't actually see it in action, but the replicas were now distributed out to the 2 nodes that were not part of the cluster originally that we added in. So now it all kind of got scaled out, and Service Fabric is going through and cleaning things up a little bit.
Well, I'm running Chaos, so...
You're running Chaos. Okay, great. So that's Chaos doing these things. There you go.
Right.
So Chaos service is just a testability thing that we offer. You basically run this service, and it's going to go and start causing random faults. It's just causing trouble in the cluster. And we do this so that you can exercise these code paths that you normally wouldn't. So you're not just testing the happy path. This thing will go in, and it'll start shutting down replicas randomly, shutting down nodes randomly, moving things around. And you can use this to then evaluate your application to look for bugs and things of that sort. So we'll leave this running while we take questions, if you guys have any questions for us.
Why don't you guys line up?
We got a couple of microphones here if you guys want to line up.
So that the people who are watching online can listen to the questions. Thank you very much.
Thank you, everybody.
Go ahead.
Please.
Hi, is this based on Orleans?
So the actor programming model that you saw, so Orleans basically paved the way of defining what does the virtual actor programming model looks like and how do you build applications in an easy-to-use programming model. So we took Orleans programming model and then put it on top of this battle-hardened platform that we have been running inside Microsoft. So the APIs will look really, really similar because they are borrowed directly from Orleans.
And the infrastructure for the state management is still the same, or is it different?
So the actors talk is going to be on the Thursday. The state management is a little bit different. It's actually much better because with Orleans, you had a volatile state that was there in the actor, but in order to do a persistent state, you had to go and do an externalized state save. Here you will see that the actor that I wrote was writing durably to an n set of replicas within the cluster itself. So it is durable by default. You can create in-memory replicated state provider as well as you can use an external state provider as well.
Here? Is this on? Okay, good.
Oh, yeah.
So I have a couple questions. One is the first question I asked on the stateful actor. You just created that class for state,
right?
And you added it to the angle brackets,
right?
And it suddenly knew you were capturing state. How did that work?
So when you derive from actor of T state, it internally is using or storing that state using the same collection technology, the reliability technology that you see for the services. And so therefore, the state that you saw, the state that I had, which was counter state, which was serializable, that serializable state as the method returns from the actor, because we are the one dispatching methods onto the actor. When the method returns, we can save the state.
Right, and you can obviously make that class be much more complicated with.
Yes, you can make, you can put any serializable class or any other data contract serializable specific class, or you can write your own class with your own serialization in it as well.
Okay.
The more details are, as I mentioned, there are more details on the actor programming model itself. At Thursday at 5 o'clock, there is a talk on the actor programming model itself where we'll go more details into all of these things.
Okay, and the other question was, so you mentioned when you started talking about the service API, when one of the nodes goes down, it gets a new address. How does it communicate the address to the client? Does the client have to be aware that the address is going to change and request that, or?
So there are two ways. So when you are using service proxy, automatically service proxy will take care for you. When you are using any other communication, let's say your own communication protocol, you'll detect a failure, right? You'll detect either a connection failure, or you're saying, hey, I'm not able to reach it, I'm getting 404, or I'm getting endpoint not found exception. You will use what we call a service resolver class and ask the system, hey, where is the new address for this service? And then the service will give you. So that's one way. The second way is that you can register for notification with the system on that class. You can say, hey, give me notification if the service moves. And so if for the communication technologies that do not sit well with respect to request response, where you can't be in between and say, hey, I have to, if a request fails. So if it is not a complaint-based protocol that you can have, you can have notification-based changes as well.
Okay.
So service discovery is kind of a built-in thing too. So when we saw that open method on the communication listener, so we return an address, that actually gets registered with what we call a naming service, and that's kind of that's the discoverability that's built in. So you can say, where's the primary replica for service with this name, and we'll hand you back that address.
Fantastic. All right, thank you.
Question
I had a
Okay,
question
go
about, I noticed you're using task parallel library. Did you guys build out your own schedulers and
No, we
things like
did
that,
not.
or are you using just the standard?
Yeah,
vanilla?
we're just using standard task scheduler. And we've done scale test internally as well for the actor framework. We've done scale test, and we didn't find any difference in terms of if we wrote custom or if we did something else.
Okay, and then for like hosting, like IIS, is this something, you would set it up in IIS and host it there, or do you build a Windows service? Like how exactly does the executable kind of in the code get kind of tied together? So
your service actually runs in its own executable. It's easier to think of it as a console application. So you actually have an exe, and your services get instantiated within that host. So it's all self-hosted. So you wouldn't use an external thing like IIS, for example. If you're doing ASP.NET, you would do a self-host ASP.NET. And so with ASP.NET 5, that's actually kind of the model they're moving to. It's kind of a parallel to how we separate out the application from the host. In the web world, they're kind of doing the same thing now, separating out the host from the application. So you don't have IIS really anymore. You have bits and pieces of IIS that you kind of pull in, and you host it in your own process. And hosting your own process is exactly what you do with Service Fabric.
Interesting. Okay, thank you.
You have a question here.
So the concept of reliable data structure that you talked about is only exist in Service Fabric's framework.
Yes.
Right?
So as far as we know, this is the only technology that allows you to create reliable collection as easily as you saw today,
Right.
and be really consistent and allow atomicity across those collections.
Okay, so can you talk about the use case for upgrading a deployment? So if you have your service installed in the Fabric
Correct.
and running, and it's a stateful service,
Right.
And if you have to upgrade your deployment, can
Right.
you talk about that?
Yeah, so there was a talk just before that where we actually took a stateful service, we did an upgrade. So I'll talk briefly about it. There is a session coming up. Can you go put
Yeah.
that slide? Where we are actually talking about managing and deploying application. So the cluster that you saw had 9 nodes. They were in 3 what we call upgrade domains.
Right.
And as you roll your code, the upgrade goes from upgrade domain to an upgrade domain. And every application instance that you create of your application type is a unit of upgrade. You can actually do A/B testing. So you can say, I'll upgrade some applications, I won't upgrade other applications. We also have the health subsystem, and if we notice any failures during the deployment, we will roll back the deployment. You can define custom health policy. So all of that is in the talk that talks about deploying and managing services. So there's more, they go a little bit more in depth in terms of how do you actually manage and deploy.
Okay, sounds good. Thank you.
Good question here.
So, as a follow-up to the earlier question on the endpoint URLs, is there a way, if you had a public endpoint that needed to be at a consistent DNS address, that you could host that within Service Fabric?
Yes, you can, but typically what happens is that if you saw the stateless front end that we saw, that's sitting behind the Azure Load Balancer, which is the public endpoint, and so which is a well-known endpoint, so that's where you are hitting. And what we do is that those stateless services that you saw, you typically have what we call an instance count of -1 with a placement constraint to say, hey, I'll run it on front-end nodes. And so it will appear on all of those front-end roles. As you add nodes, it will appear there again on those nodes. And those are being served by your Azure Load Balancer with the fixed set of from say, hey, this is my public IP to those ports, right? From there, you are using service proxy or resolution in order to go to your stateful services that are moving. Now, if you are running within an enterprise where you have a direct connectivity of whatever new address that your service comes up on and listens to, you can skip that first tier as well and connect directly to your backend stateful services as they move around and can resolve from your client.
So it can be kind of a cooperative effort with your load balancer, right? If you think of it in Azure today, you might stand up some web roles, and then you know that your web roles are listening on port 80, and your Azure load balancer knows about them, and so you have a VIP that sits in front of those. You basically set the exact same thing up here. You can get a static port. You can ask for port 80. We'll give you port 80 and make sure it's ACLed and all that kind of stuff. And then you can basically say, I want this many instances of that stateless service living on certain nodes, and you can restrict it to just certain nodes, and then you can tell the Azure load balancer only look for those nodes, that kind of thing. The talk that's coming up later this week, we'll talk a little bit more about how you actually do those placement constraints, so get a better idea of how to do that there.
Yeah, and I think you already answered the follow-up I had, but basically it seems like then you could choose which availability zones, which region, all of the details there that you're deploying this within. Can it live within your own, one of your virtual networks, all of that?
Correct. So the first talk, which says deploying and managing services, which will talk about when we provide a hosted offering in terms of how hosting these clusters within Azure. We'll start with certain functionality and we will expand as it goes. Cortana example, which was given, it actually spans 3 different data centers, and there was an event where one data center went down. The cluster spanned all 3 data centers, but their service did not have an outage. The service orchestration talk will talk about how to basically restrict. So for example, if you have a front-end nodes and a back-end nodes, and you say, well, my back-end nodes are using stateful services, and I want them to be SSD-based because I want them to have a larger hard disk compared to my front-end node, which are not storing any data. So you may have 2 different types of machines within your cluster, and you can restrict certain set of microservices to go on certain set of nodes. So you can define properties on the node. You can also define, as he mentioned, capacities, and we'll balance based on capacity. We'll also honor your placement constraints. So more of that is in the service orchestration talk.
All right, thank you.
Yeah, question on the right side.
Okay.
So how does your stateful services work with, like, let's say, a traditional SQL backend? So at the end of the day, I'm running my online transactions in my stateful services, but my BI group really needs me to write this all off to a table when I'm done so that they can batch process it overnight because they're not fast enough to catch up with me running with these kinds of services. What does that look like at the 50,000 foot level?
Yeah, so you will basically do your OLTP queries from the stateful services, but for your BI stuff, you can periodically move the data to your backend SQL store or Hadoop clusters, and you can run MapReduce jobs, or you can run the Power BI tools on top of that.
So is my application responsible for that periodic moving, or can I set up at Fabric to push it off for me?
So you can do backup and restore for disaster recovery, but for your BI analytics, you know your data better because you are the one who is writing it. So therefore, you would be the one taking care of moving it into appropriate format to your backend databases.
Thank you.
Thank you very much.
All right, thanks, everybody.